How golf balls are made. Golf, a sport with origins in Scotland, has evolved into one of the most popular recreational activities globally. In the United States alone, over 24 million individuals engage in this sport, with more than 8,000 professionals among them. Golf tournaments attract a significant number of spectators and have been widely broadcasted on television since the 1960s. The sport's popularity has even led to the establishment of a dedicated cable channel and numerous computer games focused on golf. The objective of golf is to use a variety of clubs to drive a small ball into a sequence of either 9 or 18 holes, traversing a course designed with numerous obstacles, and achieving this in as few strokes as possible. Players are allowed to carry up to 14 clubs of different shapes, sizes, and lengths to navigate the course. The standard golf ball in the United States measures a minimum of 1.68 inches, 4.26 centimeters, in diameter, while the British counterpart is slightly smaller. A typical golf course features 18 holes distributed over a landscaped area that incorporates various hazards, such as water bodies, sand traps, bunkers, and trees. The difficulty of the course is heightened by the varying distances between holes. Each hole's play begins at the tee area, where players drive the ball into the fairway. The length of each hole can range from approximately 150 to 600 yards, 135 to 540 meters. Successful players can drive the ball more than 200 yards, 180 meters, from the tee and approach most holes with fewer than 3 shots. The end of the hole, known as the putting green, is where the ball is putted into the hole or cup to complete the play. Golf is usually played in groups of 2 to 4 people who navigate the course together. The ball must be played from its resting place, except under specific circumstances. In stroke play, the total number of strokes used to move the ball from the tee to the hole is recorded as the player's score for that hole. The player with the fewest strokes to complete the course is the winner. In match play, scores are compared after each hole, and a player wins, loses, or ties, halves, each hole. Each hole has a designated number of shots, par, required to reach it, typically based on its length. A birdie is achieved when a player scores 1 stroke less than par on a hole, while an eagle represents a score 2 strokes under par. A hole-in-one occurs when a player drives the ball into the hole with a single stroke. The golf ball market is a significant industry, generating around $550 million in annual sales, with over 850 million golf balls manufactured and shipped each year. Modern golf balls are constructed in 2 or 3 parts. 2-piece balls, made of rubber and plastic, are favored by casual golfers for their durability and account for 70% of all golf ball production. In contrast, 3-piece balls, used primarily by professional golfers, consist of a plastic cover, rubber thread windings, and a core that may contain gel, liquid, often sugar and water, or be solid. The dimple pattern on the ball's surface enhances its flight performance. Golf ball design is intricately tied to the patterns and configurations of dimples on its surface. The most common dimple patterns found in modern golf balls include the icosahedral, dodecahedral, and octahedral arrangements. Each pattern is based on specific polyhedral shapes. Icosahedral pattern. This pattern is derived from a polyhedron with 20 identical triangular faces, akin to a 20-sided die. Some golf balls feature an icosahedral pattern with as many as 500 dimples. Dodecahedral pattern. This pattern is based on a polyhedron with 12 identical pentagonal faces. Octahedral pattern. This design utilizes an 8-sided polyhedron with triangular faces. The general principle in golf ball aerodynamics is that a higher number of dimples, typically around 0.15 inches, 0.38 centimeter in diameter, improves the ball's flight characteristics. Impact of dimple size and depth on performance. The size and depth of the dimples play a crucial role in determining the flight and behavior of a golf ball. Shallow dimples. These create more spin, which increases lift and keeps the ball aloft longer. Consequently, the ball has a higher trajectory and less roll upon landing. Deep dimples. These generate less spin, resulting in a lower trajectory and more roll after hitting the ground. This is beneficial for achieving greater distances on low shots. Small dimples provide lower trajectory and better control, especially in windy conditions. Large dimples result in higher trajectory and extended flight time, enhancing the overall distance. Customization and performance categories. Technological advancements have enabled manufacturers to tailor golf balls to suit different player needs, weather conditions, and specific course requirements. Golf balls are categorized based on performance attributes, distance and durability, designed for maximum distance and longevity. Control and maneuverability, focused on precision and handling, distance and control, balanced for both long shots and accuracy. Slow club head speed, optimized for players with slower swing speeds. Within these categories, there are over 80 different models, each utilizing unique construction materials and designs. Regulatory standards by USGA. The United States Golf Association sets stringent rules for golf ball specifications, which include maximum weight 1.62 oz, 45.93 g. Minimum size ensuring the ball is not smaller than 1.68 inches, 4.26 centimeter in diameter. Spherical symmetry. The ball must be uniformly symmetrical.
Initial velocity must not exceed 250 feet per second, 75 mph,
with a maximum tolerance of 255 feet per second, 76.5 mph. Overall distance. The ball's carry and roll distance should not exceed an average of 280 yards, 84 meter, with a maximum of 296.8 yards, 89 meter. These standards are reviewed and updated annually, ensuring consistency and fairness in the sport. Evolution and materials in golf ball manufacturing. The market currently includes approximately 850 models of golf balls that conform to USGA standards. Recently, slightly larger balls, about 2% bigger, have been introduced. These balls feature softer cores and thicker, more durable covers, resulting in straighter and longer shots. Composition of golf balls. Two-piece balls comprise a solid rubber core with a thermoplastic ionomer resin cover. The rubber starts as a hard block, which is heated and molded into a sphere. Three-piece balls consist of a smaller solid rubber or liquid-filled center surrounded by rubber thread wound under tension and covered with ionomer or balata rubber. In the 1970s, the introduction of polybutadiene, a petroleum-based polymer, improved the ball's interior by providing more bounce. However, this material was initially too soft. Subsequent research at Spalding revealed that incorporating zinc could strengthen polybutadiene, leading to widespread adoption of this reinforced material by other manufacturers. The production of golf balls, particularly the advanced three-piece variants, involves a highly intricate process. The complexity of manufacturing a three-piece golf ball requires over 80 distinct steps and 32 inspections, often taking up to 30 days to complete a single ball. In contrast, the simpler two-piece balls can be produced in approximately half the time and are ready within a day. Step 1. Creating the core. The core of a two-piece golf ball is formed through a process known as molding. This involves a blend of several chemically reactive ingredients that form a rubber-like compound. The application of heat and pressure results in a molded core, typically about 1.5 inches, 3.75 centimeters in diameter. Step 2. Forming the cover and dimples. In the injection molding process, the core is centered within a mold cavity using pins. Molten thermoplastic is then injected into the cavity surrounding the core. The combined effect of heat and pressure causes the cover material to flow and bond with the core, creating the dimpled pattern and final shape of the ball. Once the plastic cools and hardens, the pins are retracted and the finished balls are extracted. Step 3. Compression molding for three-piece balls. Three-piece balls, due to their more complex structure, undergo compression molding. Initially, the cover material is injection molded into two hollow hemispheres. These hemispheres are then positioned around the core and heated. A mold then presses them together, fusing the cover to the core and forming the dimples. This method prevents distortion and breakage of the rubber threads within the ball. Step 4. Finishing the surface. After molding, rough spots and seams on the cover are polished off. The balls receive 2 coats of paint, applied uniformly by spray guns, while the balls spin on posts. Next, logos are stamped onto the balls. Finally, a clear coat is applied to provide a high sheen and scuff resistance. Step 5. Preparation for market. Once painted, the balls are placed in containers and moved to large dryers. After drying, they are ready for packaging into boxes and other containers, prepared for distribution. Quality control. Quality control in golf ball manufacturing is rigorous, involving various tests and inspections to ensure compliance with standards. X-ray inspections and compression ratings. Three-piece balls undergo X-ray inspections to ensure the centers are perfectly round. Compression ratings measure the resilience of compression-molded wound golf balls, though these ratings do not apply to two-piece balls. Instead, two-piece balls are evaluated using a coefficiency rating, which measures the coefficient of restitution by comparing initial and return speeds after the ball strikes a metal plate. Mechanical testing and performance verification. Golf balls are subject to mechanical testing to verify compliance with the United States Golf Association, USGA standards. Specialized equipment, such as the True Temper Mechanical Golfer, Iron Byron, and the ball launcher, is employed to simulate various playing conditions and measure performance metrics. Iron Byron, modeled after the swing of golf legend Byron Nelson, can be configured with any club and adjusted for different swing speeds. For standard testing, it is typically set up with a driver, 5-iron, and 9-iron. The ball launcher propels balls at varying velocities, spin rates, and launch angles, simulating diverse golfer profiles. Performance data collected include the apogee angle, carry distance, total distance, roll distance, and statistical accuracy area. The meticulous manufacturing process of golf balls, especially the technologically advanced three-piece variants, reflects the intersection of material science, engineering, and quality control. Each step, from forming the core to the final coating, ensures that golf balls meet the stringent performance standards required by professional and amateur golfers alike. Through continuous innovation and rigorous testing, manufacturers strive to enhance the performance and reliability of golf balls, contributing to the evolution of this beloved sport. The sport of golf, with its rich history and widespread appeal, continues to be a popular pastime for millions around the world. The scientific principles underlying the design of golf balls and the strategic elements involved in gameplay contribute to its enduring allure. Whether for casual enjoyment or professional competition, golf remains a game that combines skill, precision, and a deep appreciation for the nuances of the sport. How baseball was created. Baseball, often called America's pastime, has a rich history that traces back to the early 19th century. The game evolved from a British sport known as rounders. Rounders involved hitting a ball and running around bases, much like baseball, but with simpler rules and a larger, softer ball. This game, popular in England, was brought to North America by early settlers and gradually evolved into the sport we know today. In 1845, Alexander Cartwright of New York played a crucial role in shaping modern baseball. He formalized the rules, which distinguished baseball from rounders by introducing a smaller, harder ball and a more structured field layout. Cartwright's rules laid the foundation for baseball's standard regulations, setting the stage for its rapid growth in popularity. By the turn of the 20th century, baseball had established itself as a major sport in the United States. Initially, the baseballs used had a round rubber core, but in 1910, this was replaced by a livelier cork-centered ball. This new design increased the ball's resilience and improved the game's dynamics. 2 decades later, the cushioned cork model was introduced, providing even more consistency in performance. One notable modification occurred in 1974, when a shortage of horsehide led manufacturers to switch to cowhide covers. This change was necessary due to a decrease in the horse population, which made horsehide scarce and expensive. Raw materials. A baseball consists of 3 primary components: the core, often referred to as the pill, the windings, and the outer covering. Each component plays a critical role in the ball's performance, durability, and overall feel. The core, pill. At the heart of a baseball is the pill, a small sphere made of cork and rubber. The pill measures 13/16 of an inch, 2.06 centimeters, in diameter, and is encased in 2 layers of rubber, a black inner layer and a red outer layer. These layers are meticulously crafted to ensure the pill is perfectly round and resilient. The black inner layer consists of 2 hemispheric shells joined by red rubber washers. This construction provides the necessary hardness and elasticity. Windings. Surrounding the pill are 4 distinct layers of yarn windings, which help maintain the ball's shape and add to its resilience. The first wool layer is the thickest, bringing the unfinished ball's circumference to 7 3/4 inches, 19.68 centimeters. Each subsequent layer increases the ball's circumference until it reaches the standard size of approximately 9 inches, 22.86 centimeters. Wool is chosen for its natural resilience and ability to return to its original shape after being compressed, ensuring the baseball retains its perfect roundness despite repeated impacts. Outer cover. The outer cover of a baseball is made from number 1 grade, alum-tanned full-grain cowhide. This high-quality leather is primarily sourced from Midwest Holstein cattle, known for their superior grain and smooth texture. The cover must be white and is stitched together with 88 inches, 223.50 centimeters of waxed red thread. Before being used, cowhides undergo rigorous testing for thickness, grain strength, tensile strength, and other factors to ensure they meet Major League Baseball's strict standards. Manufacturing process. The manufacturing of a baseball is a meticulous process that involves molding rubber, winding fabric, and sewing cowhide under carefully controlled conditions. This ensures that each ball meets the exacting standards required for professional play. Molding rubber. The process begins with the creation of the pill. 2 hemispheric black rubber shells, each approximately 5/16 of an inch, 39 centimeters thick, are molded around a rubberized cork sphere measuring 13/16 inch, 2.06 centimeters, in diameter. The small openings between these shells are sealed with red rubber gaskets. A thin layer of cement is applied to the pill to help secure the wool yarn during the winding process. Winding fabric. Wool yarn, stored under controlled conditions, is wound around the pill by computerized machines that maintain high tension to eliminate soft spots and create a uniform surface. The wool yarn is wound in 3 layers. The first layer consists of 121 yards, 110.6 meters, of 4-ply gray yarn. The second layer has 45 yards, 41.13 meters, of 3-ply white yarn, and the third layer comprises 53 yards, 48.44 meters, of 3-ply gray yarn. A final layer of 150 yards, 137.1 meters, of fine poly cotton finishing yarn is then wrapped around the ball to protect the wool yarn and hold it in place. The wound ball is trimmed of excess fabric and dipped in an adhesive solution to prepare for the outer cover. Sewing. Hide. The cowhide covering is cut into 2 figure-8 patterns, each covering half of the wound ball. These patterns are dampened to increase pliability and coated with adhesive on the inside. They are stapled to the wound ball and hand-sewn together using 88 inches, 223.2 meters, of waxed red thread. The sewing process involves 108 stitches, with the first and last stitches completely hidden. This hand-sewing process takes an average of 13 to 14 minutes per baseball. After stitching, the staples are removed and the ball is inspected. It is then placed in a rolling machine for 15 seconds to level any raised stitches, ensuring a smooth, uniform surface. The baseballs are then measured, weighed, and graded for appearance. Acceptable baseballs are stamped with the manufacturer's trademark and league designation. Quality control. Quality control is a critical aspect of baseball manufacturing. Each shipment of baseballs undergoes rigorous testing to ensure they meet Major League Baseball standards. The key test is the coefficient of restitution, COR, which measures the ball's resiliency. The COR test involves shooting a baseball from an air cannon at a velocity of 85 feet per second, 25.90 meters per second, at a wooden wall from a distance of 8 feet, 2.43 meters. The speed with which the ball rebounds off the wall is measured. Major League Baseball specifications stipulate that a baseball must rebound at 54.6% of the initial velocity, plus or minus 3.2%. This test ensures that the baseballs have the proper amount of liveliness and are neither too dead nor too bouncy. This test simulates the wear and tear a baseball undergoes during a game. To prove their strength, baseballs must distort less than 0.08 inch, 0.20 centimeters, when compressed between two anvils. These stringent tests ensure that every baseball used in Major League games meets the highest standards of performance and durability. Baseball has long been celebrated as more than just a sport in the United States. It is an integral part of American culture and history. Mark Twain, the famous American writer, once described baseball as the very symbol, the outward and visible expression of the drive and push and rush and struggle of the raging, tearing, booming 19th century. This sentiment captures the spirit of baseball and its significance during a transformative period in American history. In the 19th century, baseball emerged as a favorite American sport because it was faster paced and more physical than its English predecessors, such as cricket, town ball, and rounders. Although cricket was played wherever English immigrants settled in the United States, Americans seemed to prefer the more aggressive nature of baseball. Initially played by gentlemen in fashionable clothing, the game and its equipment began to change once formal rules were written down in the 1840s. The game's popularity surged after the Civil War, becoming a unifying force in a nation healing from conflict. During this time, the baseball itself underwent several changes. The first baseballs used were too lively, often leading to scores that exceeded 100 runs. To address this, a less lively ball was introduced, but it proved too dead, as evidenced by a scoreless 24-inning game that convinced many that hitters were at a disadvantage. These experiments with the baseball's design were crucial in finding the right balance for the game's integrity and enjoyment. The marketing and mass production of baseballs played a crucial role in the sport's growth and the establishment of its enduring legacy.
How are basketballs made? Have you ever wondered how basketballs are made? Basketballs, like volleyballs and medicine balls, are specialized rubber balls designed for optimal performance in the sport of basketball. Although the materials have evolved, the basic design of the basketball has remained relatively constant. This detailed guide explores the development and design processes involved in creating a basketball. The manufacturing of a basketball can be divided into 4 main phases. Each phase is crucial to ensure the basketball performs optimally. These phases are creating the inner bladder, shaping the interior of the basketball, making the cover of the ball, final testing and analysis. Phase 1. creating the inner bladder. The inner bladder forms the core of the basketball. It is made from black butyl rubber, which is known for its excellent air retention properties, providing the necessary bounce for the ball. The butyl rubber is melted and molded into flat panels. These panels are then joined to form the shape of a basketball. This step requires precision to ensure the bladder is seamless and can hold air without leaking. Air filler installation. A 1-inch hole is pierced into the bladder to install the air filler tube. This tube will be crucial for inflating the basketball to the desired pressure. Inflation and testing. The inner bladder is inflated and left for 24 hours to ensure it holds air properly and maintains its shape. This step is essential to verify the bladder's integrity and air retention capacity. If the bladder loses air during this period, it is discarded and not used in further production. Phase 2. Shaping the interior of the basketball. The initial shape of the inner bladder is imperfect, requiring further refinement. Thread wrapping. The bladder is wrapped with polyester or nylon threads using a machine. This step helps shape the bladder into a perfect sphere and prevents deformation. The threads also add an extra layer of strength to the bladder, ensuring it can withstand the impacts and pressures of the game. Thread types. Polyester threads are typically used for street basketballs, which are exposed to rougher surfaces and conditions. Nylon threads are preferred for professional basketballs due to their superior durability and strength, providing a more consistent performance. Layering process. The bladder is carefully layered with these threads in a crisscross pattern. This intricate layering process ensures that the ball maintains its shape and improves its overall resilience and bounce characteristics. Phase 3. Making the cover of the basketball. The outer cover of the basketball can be made from various materials, including high-quality leather, synthetic rubber, or regular rubber. Material preparation. The chosen material is cut into 6 separate panels. The panels must be cut with precision to ensure they fit together perfectly when assembled around the bladder. Leather. High-quality basketballs use leather, which is stitched together around the ball. Leather provides an excellent grip and a premium feel, making it the preferred choice for professional and indoor basketballs. Rubber. Synthetic or regular rubber panels are glued onto the ball. Rubber covers are more durable and water-resistant, making them suitable for outdoor use. Stitching and gluing. For leather basketballs, the panels are stitched together using durable threads, ensuring they are securely fastened. For rubber basketballs, a strong adhesive is used to glue the panels onto the bladder. Customization. If customization is required, decals or graphics are applied at this stage. These are typically added using adhesive stickers. Custom designs can include logos, branding, and other graphics that personalize the basketball. Decal application. The designs are pressed onto the ball, ensuring they adhere properly before the stickers are removed, leaving the graphic in place. This process requires precision to avoid bubbles and ensure the graphic is smooth and properly aligned. Phase 4. Final testing and analysis. The final phase ensures the basketball meets all necessary standards and is ready for commercial use. Bounce test. The ball is dropped from a height of 72 inches. It must bounce back to a height between 52 and 56 inches to pass. This test ensures the ball has the proper elasticity and air pressure. Detail inspection. Decals, graphics, and any glue residues are checked and cleaned up. Inspectors ensure that the ball's surface is smooth, the graphite ICs are clear, and there are no visible defects. Weight and size measurement. The basketball is measured to ensure it meets the standard size and weight regulations. Professional basketballs must adhere to strict guidelines for diameter and weight. Durability testing. Some balls undergo additional durability testing, including exposure to extreme temperatures and repeated impact testing to ensure they can withstand various playing conditions. Packaging. The approved basketballs are then packaged in plastic bags or cardboard boxes and shipped to distributors. Packaging also involves labeling the product with necessary information, including the brand, model, and usage instructions. The process of making a basketball is intricate and involves several key steps to ensure the final product meets the required standards of performance and quality. From creating the inner bladder to the final testing phase, each step is crucial in producing a basketball that is both durable and functional. The blend of traditional techniques and modern materials ensures that basketballs continue to perform at the highest levels, whether on a professional court or a neighborhood playground. The manufacturing process reflects the evolution of the sport itself, adapting to new technologies and materials to provide players with the best possible equipment. Whether you are a professional athlete or a casual player, understanding the effort and precision that goes into making a basketball can enhance your appreciation for the game.
That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.